In match problem 3, we're coming back to this surfboard company that a lot of these match problems keep referring back to. So now what they've done is established a yearly profit equation. X is the number of standard boards, Y is the number of competition boards. What we want to find out is how many boards of each type, so how many of each type of board, should be produced to realize their maximum profit and actually come up with that maximum profit. So we want to come up with the values for X and Y that are going to yield maximum profit, meaning this company is making as much money as possible. So this is just an application of that second derivative test. So we'll start off by finding the first derivative with respect to X, which will be negative 132X plus 132Y plus 132. We'll set that equal to 0. This is in terms of X and Y, so we can't solve it yet. We'll need to find our first derivative with respect to Y, and then look at solving that system of equations. So f, or I guess we should be using capital P here, profit function. But our given function differentiated with respect to Y is going to be 132X minus 198Y minus 66 equal to 0. So now we have two equations, each with two variables, so we need to do something to solve this system. In the last match problem, we looked at using substitution, but the other method is elimination. So what we can do is bring this function over and just add these two expressions together. So the reason that this is kind of a preferable method in this case is that we can kind of see negative 132, 132, that's just going to be 0, so those are going to cancel out. 132y minus 198y is going to give us negative 66y, and then 132 minus 66 will give us 66 equal to 0. So subtracting 66 from both sides, dividing by negative 66 is going to give us a value of y equals negative, or y equals positive 1. Once we know that y equals positive 1, we can substitute that back into either of the two original equations. We'll substitute it into our derivative with respect to y, minus 198. So we get 132x minus 198 times 1 minus 66 equals 0. And then we're just solving for x, which should yield x equals 2. Now, keep in mind that these values for x and y are in thousands, so we're not saying we should produce 2 boards, we're saying we should produce 2,000 boards, 1,000 boards, possibly. So this is still just a critical point. So our kind of initial guess here is that we should be producing 2,000 standard boards, 1,000 competition boards, but we still need to apply the second derivative test to ensure that that really is a maximum for the function. So we'll find a equals f differentiated both times with respect to x, b equals our function differentiated with respect to x, differentiated with respect to y, and our function differentiated with respect to y, and then with respect to y. Again, what we're referencing back to is that profit function, so I should probably be using p instead of f, but for some reason I can't seem to break that habit for this problem. So we'll evaluate a, which is going to be f sub xx. So our second derivative with respect to x is going to be negative 132. Our value for b is going to be the first derivative with respect to x. Second with respect to y is going to be positive 132. And our value for c is taking both derivatives with respect to y is going to give us negative 198. So then we need to find AC minus B squared. So in this case, there are no x or y values in our second derivative, so it's literally just taking these values and calculating this expression. So A is negative 132 times C, which is negative 198, minus our value for C, which is 132, squared, is going to give us a result of 8,712. All that we really care about is that that's a positive result. And then we can compare A to 0. In this case, our value for A is negative 132. That result is less than 0, which according to the second derivative test means we have a local maximum. So our profit function has a local maximum at P of 2, 1. So switching back to using P instead of F there. And then if we plug x equals 2, y equals 1 into our original profit function, that should give us a result of 80. So to interpret what all that means, and to kind of fully answer the question here, what we're saying is that a maximum profit of $80,000, since again that profit is in thousands of dollars, is obtained by producing and selling 2,000 standard boards. So this is that value x equals 2, and 1,000 competition boards. And this is that value y equals 1. So we have x equals 2, y equals 1, and our profit function evaluated at 2, 1 being equal to 80. But each of those in thousands of dollars means we're going to generate a profit of $80,000 by producing 2,000 standard boards and 1,000 competition boards.